Now let's take a moment to look at some graphs of functions. And we're going to talk in the last set, 11.5, we're going to talk about what actually makes a graph of a function, or how can you tell by looking. So just take my word for it. We have two functions here, and you can see they write y equals g of x. So this is g of x, this is f of x. Why is one called f and one called g? Well, just so that they have two different names, because they're two different functions. So we could say this is almost like a linear function, except for it's not continuous, so it is a line segment, because you see it has a stop and a start, or actually a start and a stop, right? And then this looks sort of cubic, but we don't have an equation for it. It's just a fancy line or a fancy curve, okay? And that's f of x. So when we look at these questions here, we want to be able to answer the questions based on the graph. Now remember that every single graph is just a collection of an infinite number of ordered pairs, right? So like an ordered pair here, what's that point? Yes, 0, negative 6. That's a y-intercept. What's this point here? 0, negative 2, right? What do those points have in common? Yes, and where is the 0 located? On the x. The x. So y-axis, just so you know, x equals 0 is the equation of the y-axis. That's why whenever you plug in x equals 0, you always get a y-intercept, right? Interception. Football. Okay. What about this point here? What's the ordered pair of this point? Negative 6, 0. And I like how you switched that order, right? Because order matters. Negative 6 is the x and the y is 0. What about this point right here? Negative 2, 0. These are what we call x-intercepts. What makes them an intercept? The fact that they're on the x-axis. What do you notice that these 2 points have in common? The y is equal to 0. So that means the equation of the x-axis is y equals 0. Every single point on the x-axis will have one thing in common. What will they have in common? Do you know? The y will always be 0. So whenever you set y equal to 0 and you find x, you have found an x-intercept, my friends. Whenever you plug in x equals 0 and you find a y, you have found an y-intercept. Exactly. Okay, so if we want to evaluate f of negative 3, what is that negative 3 telling you? What does it mean to you? It's a what? It's an x. So I can go to negative 3, and then I want to find my f curve. Here would be g of negative 3, but here would be f of negative 3. F of negative 3 is equal to what? Yeah, or it's actually equal to 3. So negative 3, 3 is that ordered pair. That means the y value is 3. Evaluate f of 6. So I go, that's my x. I go to x is 6. I go to my curve, which is f, and I'm like, wait a minute. There's a hole there. What is f of 6, do you think? It's actually undefined. Do you see why it's undefined instead of negative 2? It's not filled in. Exactly. It's an empty circle, so it's undefined. There is no value. So we would say it doesn't exist or it's undefined, right? There's no actual number. Does everybody get why that is? Yes? Okay, what about this one? This says solve f of x equals negative 5. So the problem is, am I going to go to negative 5? Is that my answer right there for that? No. What's the difference? What do I have to do to solve for negative 5? Solve for x when y is negative 5, right? So this means that y equals negative 5. Well, just like I told you that y equals 0 is this line, this line right here, what's the equation of this line that I just drew? It's actually y equals -5. Do you see why that is? Okay, so y equals -5 has this point, has this point, and has this point. Yes. That's what we do. We're going to solve where y equals -5. We want the x values. So my ordered pair here is -7, -5. Who can tell me what's the ordered pair there? What do you think? Is it that point? It looks like about a half, right? A -half. It's not quite on the 0. You see there's the 0. So I'm going to say that's -1/2, comma, -5. You see that ordered pair? What's the ordered pair of this point here? It's a little over 4. 4.2, sure, -5. So that means we want all the x values that correspond to y equals -5. So what would the x values be? (4.2). Love it. So those mean this is the solution set. It means these are the x values. Okay, so there's all those 3 ordered pairs, and I think that's the easiest way to do it. If you know that you're solving, you could draw the line y equals -5 and see all the places it crosses, because most people will just find one of them and they won't necessarily find all of them. Okay, this says solve where f of x is less than g of x. So if we go on the graph, here's g of x and here's f of x. We want to know the places where f of x is below the line, because that's saying f of x is less than g of x. Here f of x goes over g of x, it's above, so we don't want that point, we don't want that part. Here f of x is greater than g of x because it's above the line. So we want all the places where f of x is below g of x. So that's an infinite number of places, isn't it? It's an infinite number of points. So we could use an interval, right? It says use interval notation for a solution set. So who can tell me what's the interval where f of x is less than g of x? Including -7, because we're solving, that's x values, right? All the way up to -5. And actually, I just realized I put bracket, but I need parentheses. Does everybody see why I would have to change my bracket to parentheses? The whole thing is, though, this is where it's less than or equal to, right? Isn't that true? Hold on. Is that right? But wait a second. Less than. I have to think about that. Oh, actually, you know what? This side, wait. Let me think. I think actually this side could be included, but you wouldn't include here because that's not going to, we don't want to exactly be equal, we want to be less than. So you want bracket, parenthesis. And then is there another place where f of x is less than g of x? So I'm going to union, because I'm going to skip all this part. I'm going to go from -2 all the way to 4. And I'm not going to include those endpoints. Okay? Because it's touching the line. If it's touching the line, it would be exactly equal. But I want to go all the way up to the line, but not exactly touch the line. Okay? What about this one? F of x is less than or equal to -6. So I could do the same thing. This line right here is y equals -6, right? So I want to know, when is my function f, that's this curvy line, when is it below negative 6? And that's this whole area is less than or equal to negative 6. Can anyone tell me that interval? It's getting kind of messy on the screen, huh? But it's just basically this whole area is where my function dips down below the line y equals negative 6. So it's going to be, and okay, 0 to 4. What should I put, parentheses or brackets? Brackets on both. Why brackets on both? Because of the or equal to. If it had said f of x is less than negative 6, how would that change the interval? That would be the parentheses, right? That's solve. Okay, so this is two different questions, and it's based on that inequality. One where it's less than or equal to, one where it's just less than. You see the difference? Okay? State the domain of f of x. So the domain is all the x values. X value, x value, x value, all the way to here. So think about the domain. Where does it start? Where does it stop? Who can tell me that? Okay, yes. So starts at, what we were doing x values, remember, right? So from negative 7 all the way to 6, from, negative 7 to 6, what do I put around my numbers? Parentheses, brackets, does one side get a bracket? Which side gets a bracket? Okay, which side gets a parenthesis? There we go. Okay, the range. Remember the range goes from here up, from the bottom to the top. What's the smallest x value? I mean y value. Sorry, I meant y value. Yes, negative 8. Now you can't see it, but that point is actually included. So that would be from negative 8, and then what's the maximum? All the way up to 4 is the maximum. Oops, I'm not even on the screen, you guys. And what should I put around those numbers? Both get brackets. Now you might be a little bit concerned because you're like, well, what about negative 2 on a y? But actually, y equals negative 2 right here and right here. So that, even though that one's open, you can still include the negative 2 because it's still included in the function. You get that? Okay, any questions about this one?